Look at these cards. For decades, giving instructions to a computer meant physically punching holes into cardstock. Every line of logic required grueling manual labor. We don't write software this way anymore. Today, by abstracting those holes, we are removing the act of typing syntax altogether. This animated diagram shows a donut chart hitting 85%, the share of professional developers using AI coding agents today. Next to it, a stacked area chart crosses a 41% threshold, the current volume of all new code generated entirely by AI. This rapid adoption has birthed a practice known as vibe coding. You type out what you want in plain English, copy whatever the AI spits out, and if it breaks, you paste the error message right back into the prompt until a working app eventually materializes. Pushing out a prototype in 10 minutes feels like magic, but treating that sprint as a solved model for enterprise software is a dangerous illusion. Building a toy app to parse your grocery list is entirely different from deploying code that handles live financial transactions or manages health records. This spectrum illustrates modern AI development. On the left, the red vibe coding zone prioritizes speed, relying purely on human vibe checks. To build trust, you must move to the blue agentic engineering zone on the right, replacing guesswork with automated test suites, CI/CD gates, and strict evolution models. You cannot reach that structured engineering side by just cramming more instructions into your system prompt. If you keep adding API keys, style guides, and tools into one long text box, the model stops paying attention. It picks the wrong tools or forgets early commands. This decay is called context rot. When a bloated prompt collapses under its weight, the agent starts hallucinating. It might invent variables or follow a procedure that no longer exists, or write logic that directly contradicts your core architecture. In traditional development, security is a binary gate. Either the code compiles and the credentials are valid, or they aren't. AI generation is highly variable. An agent can hold a perfectly valid access token and still execute logic with misaligned, unpredictable intent. Writing 1,000 lines of code before lunch is a liability if that code bypasses your security controls. To survive at scale, the entire software development lifecycle has to be rebuilt. The first step in this new lifecycle is figuring out how an isolated AI model actually reaches out and touches your infrastructure. If you have 5 different AI models and 10 different tools, like Jira, GitHub, or internal databases, you traditionally have to write 50 separate custom integrations. That creates an unmaintainable web of fragile connections. The solution is the Model Context Protocol, or MCP. Think of it as a universal translator. It is an open, standardized communication layer that lets any AI model talk to any data source using exactly the same format. With MCP acting as the hands of the system, your agents can pull live records and run queries natively. You avoid bloating your initial prompt because the agent retrieves exactly what it needs, only when it needs it. This diagram maps out the internal logic loop of an autonomous agent. Notice the cycle here. It perceives a goal, plans the steps, takes action through tools, and then observes the results to correct itself. To guide that loop without overwhelming the model, we use agent skills. These are self-contained markdown folders acting as specialized playbooks, allowing one general-purpose agent to instantly swap into the role of a database architect or a UI designer. These skills rely on an architectural mechanism called progressive disclosure. This is how we cure context rot. Instead of loading every playbook at startup, the agent keeps a tiny metadata footprint in its active memory. Only when the agent hits a specific trigger does it pull the full execution script into its context window. By decoupling the state from the conversation history and isolating these instructions, the agent maintains a lean, modular procedural memory. It stays focused, efficient, and far less likely to lose the plot. Once an agent has hands and playbooks, you hit the hardest part of the equation, verifying actions that are not strictly predictable. We have to move past simple unit tests. Tests verify that a specific input equals a specific output. We need multi-turn evaluations. Evaluations judge the entire trajectory. Did the agent choose the right tools, sequence the steps correctly, and converge on the right overarching goal over time? Because this process involves an AI writing and rewriting raw scripts on the fly, you must run everything inside isolated sandboxes. You also need stateful circuit breakers to cut the connection the moment the agent attempts to access restricted environments. Without these rigid evaluation layers and boundaries, you aren't deploying enterprise software. You are just running a reckless vibe coding experiment on your production servers. By mastering standardized protocols, specialized skills, and trajectory-based evaluations, we arrive at the far right of the development spectrum, spec-driven agentic engineering. In this mode, the high-level specification, the version-controlled record of human intent, becomes the application's permanent DNA. Because agents can translate this intent into working logic instantly, the implementation itself no longer represents a labor bottleneck. This shift makes the actual lines of code a transient byproduct. If the model changes or logic needs translating to a new language, the agent reads the durable specification and regenerates a codebase that respects the original architecture. This requires a shift in how we value software. Developers are beginning to move away from an emotional attachment to manual syntax and routine boilerplate maintenance, focusing instead on the integrity of the high-level blueprint. The role of the engineer is transitioning to that of an orchestrator. The primary work now involves designing the boundaries, defining the specs, and managing a globally interoperable virtual workforce.